Intelligent biomimetic hand. Brain robotics intelligent biomimetic hand is a high-tech rehabilitation aid that integrates brain-computer interface technology and artificial intelligence algorithms. By collecting and processing electromyographic (EMG) signals generated by human neuromuscular activity, it identifies the operator's movement intention, thereby achieving intuitive control of the biomimetic hand. In order to achieve higher bionics, Brain robotics intelligent bionic hands are not satisfied with the simple appearance bionics of traditional prosthetic hands, but have achieved comprehensive bionics in terms of appearance structure, motion perception, intuitive control, etc., thereby simulating the bionic neuromuscular control pathway of human hands and constructing a direct connection between the user's brain and finger movements. The natural movement of human hands is very complex, so providing fully functional intelligent bionic hands for disabled users has become a world challenge. Brain robotics intelligent bionic hands are created against the backdrop of traditional cosmetic or functional prosthetics providing limited functionality, and traditional functional prosthetics require physical buttons or shaking the prosthetics to achieve simple predefined gesture switching. Compared to this, the Brain robotics intelligent bionic hand, which has a higher cost-performance ratio, integrates artificial intelligence algorithms and brain-computer interface technology, making it more flexible and convenient. This new feature is based on neuromuscular information sensing devices, which capture neuromuscular activity signals from the user's residual limbs and convert them into natural intuitive movements. Therefore, Brain robotics intelligent bionic hands can recognize the user's movement intention when attempting to control phantom limb movements, and convert it into bionic hand movements, thereby achieving an intuitive sense of control. By inputting the neuromuscular activity information of the user attempting to control the bionic hand, machine learning algorithms can grasp the characteristics of the user's neuromuscular activity and generate personalized models. Brain robotics intelligent biomimetic hand development and design team. The main pain point is how to control a complex biomimetic hand. Traditional prosthetic products are controlled through switching, which is like manipulating complex machinery. It is necessary to learn and remember the sequence of these switches, such as moving the muscles twice to control the opening and closing of the prosthetic hand, and moving the muscles 3 times to control the opening and closing of the index finger. This takes a long time to learn and results in poor control experience. For some operations that require speed control, such as playing the piano, typing, etc., traditional prosthetic products are completely inadequate. Another major pain point is the thumb. According to medical statistics, a hand that loses thumb function will lose 40% of its hand function, therefore requiring higher thumb function compared to other fingers. An important aspect of the implementation of thumb function lies in the extension and retraction function of the thumb, which means placing the thumb on the side of the palm and directly opposite the palm. This is very meaningful for different types of movements such as pinching cards, holding pens, using chopsticks, holding water cups, and holding armrests. However, traditional upper limb prosthetics either do not have the function of thumb extension and retraction, or can only be achieved by using another healthy hand to bend the thumb, which seriously affects the function of the thumb and also affects the function of the entire hand. Brain robotics intelligent bionic hand development and design team, non-invasive brain-computer interface technology, is a compound term consisting of 2 parts, non-invasive and brain-computer interface technology. Among them, brain-computer interface technology is a new type of human-computer interaction technology that attempts to establish a direct connection between the brain and machines, allowing people to directly control machines with their own ideas without the need for auxiliary methods such as language, text, keyboard, mouse, or controller. Non-invasive describes the implementation method of this method, which does not require craniotomy surgery, but instead analyzes the state of the brain by collecting biological signals on the surface of the human skin, and can even analyze consciousness and ideas in the future, thereby achieving control over the machine. This method does not invade the human body, so it is called a non-invasive method. So the relative risk is lower, users are more receptive, and related products are also easier to promote. However, this method is to understand the internal situation of the human body through the skin, and the information transmission path is long, so there are problems of information attenuation and noise mixing during the information transmission process. In order to overcome these difficulties, the implementation of non-invasive brain-computer interfaces should focus on researching human-machine interface materials, signal acquisition amplification, intention recognition algorithms, etc. Specifically, for brain robotics intelligent bionic hands, we need to use non-invasive brain-computer interface technology to obtain the user's movement intention, design an induction electrode that combines rigidity and flexibility to achieve stable and reliable collection of skin surface electromyography and neural signals, design corresponding signal acquisition and amplification circuits to process the collected signals, and design a motion intention recognition algorithm to identify the user's desire to control the finger movements of the bionic hand. Brain Robotics Intelligent Biomimetic Hand R&D and Design Team. Brain Robotics Intelligent Biomimetic Hand has innovatively proposed an exclusive commercial bionic hand intelligent interaction system based on brain-computer interface technology. Based on brain-computer interface technology, 8 non-invasive bioelectric induction electrodes are used to detect the subcutaneous electromyography, EMG, and nerve electrical signals of the user. It can accurately recognize the movement intention of each finger of the user, and the user can precisely control the movement of 5 fingers to make infinite gestures like controlling their own hand. The team analyzed the human hand motion spectrum, modeled after the muscle-bone structure of the human hand, and adopted a rigid flexible coupling under actuated design. Based on this driving configuration, 6 sets of position and current sensors and 2 sets of attitude and acceleration sensors were added to achieve humanoid grasping motion trajectory and adaptive adjustment of grasping force, thereby realizing the perception process of humanoid grasping operation. In addition, the team has exclusively proposed the non-invasive brain-computer interface adaptation critical period theory, breaking through the traditional adaptation theory of prosthetics and solving the problem of abandoning bionic hands. The traditional prosthetic hand cavity adopts gypsum molding technology, which has insufficient matching and comfortable wearing. In addition, traditional commercial prosthetic hands are difficult to operate, resulting in a high abandonment rate and resource waste. The team adopts 3D scanning printing technology for rapid adaptation of the bionic hand, and through active rehabilitation training, enhances the practicality of the bionic hand in daily life and the user's acceptance of the bionic hand, thereby reducing the abandonment rate of the bionic hand. Nowadays, since its mass production and launch in 2020, this intelligent bionic hand has benefited more than 1,000 people with disabilities, some of whom have worn it to complete piano performances and some have completed rock climbing challenges, opening up a new path in life. At present, in addition to intelligent bionic hands, there are also intelligent bionic legs that are being intensively debugged and waiting to be launched. In the torch relay of the Asian Paralympic Games, torchbearer Yi Jinyan made an early attempt and wore such intelligent bionic legs for the torch relay. Ordinary users only need to spend a few hours matching with the bionic hand for the first time, and then run in for 3 to 5 days to achieve precise control. Brain Robotics Intelligent Bionic Hand R&D and Design Team. The price of similar intelligent prosthetic hands internationally ranges from 500,000 to 700,000 yuan. Brain Robotics Intelligent Bionic Hands control costs through domestic substitution, modular production and manufacturing, integrated product development, and other means, successfully compressing prices to 1/5 to 1/7 of similar products. Technology has made up for the physical deficiencies of people with disabilities and given them a dazzling sense of the future. In the future, Brain Co. will bring more intelligent manufacturing to society, making the dazzling brain-computer technology in the science fiction world a reality.